Hi, everybody. In this lesson, we're going to work with scatterplots, which you looked at in 8th grade mathematics, but now we're going to look at it again. So this video will be quick, and so will the next one, because I kind of split them up. So a scatterplot, we're working with bivariate data. We're working with bivariate data, which means I have two variables. I'm looking at the relationship between two different variables here. So this first one I want to look at is I'm looking at age and the number of cell phone calls. And if we look at this, as age gets bigger, what happens to cell phone calls? It appears to be trending downwards. So there's a negative correlation here. There's a negative correlation that exists between these two. There's a negative correlation, and it appears to be linear. It appears at these points I can kind of find that line of best fit passing through those lines. So it appears to be a negative linear relationship there. Over here at scatterplot 2, it appears to be negative, but it doesn't look like I would use a line to fit through those points. So it's still a negative correlation, but it looks to be nonlinear. It looks like I would use an exponential function here. So it's not always going to be a line that I could fit through data. Sometimes we can fit those exponential functions that we studied back in November through this data between frying time and moisture content. So both of these associations are negative because as x goes up, what's happening to the y values? The y values are trending downwards. Here I have price and quality rating, and it appears like I got a whole bunch of nothing going on here. So I'm going to say there's no correlation between these two. It's just a whole bunch of scattered dots. There's nothing really going on. So I'm just going to say no correlation. Same thing here. I kind of have a bunch of dots. It looks kind of quadratic. Looks like a parabola might fit through this. But I'm going to say there's no correlation really. I can't really fit a line. There's no trend. There's no trend going on. This might be a quadratic function though. Remember those parabolas that we just studied? I could probably fit a parabola through those points. All right, it looks like, wait a second, it looks like there's a positive trend here. As the weight of the mare gets bigger, the fowl weight gets bigger. So it looks like there's a positive correlation here, a positive association. And it appears to be linear. I feel like I can fit a line through those points. Whereas here I have exterior shell length and age. It might look like a line would be good, but if we look at this data closely, I think a curve would do a much better shape. So this is positive. Why? Because it's increasing. There's a positive correlation again, but it's nonlinear. I'd probably use an exponential function again to model this data. So that's one way I can describe data is by bivariate data. Looking at the relationship between two variables is by describing is that they're positive, negative, or no correlation between the terms. So here I give you the data. We're going to have to make a scatter plot out of it. So a survey was done at CCHS to determine the effect of time spent on studying and grade point average. So look, here's one student. They studied for 2 hours. They had a 64. They studied for 4 hours. They had a 71. These numbers go together. So let me take a picture of this so I can not have to flip back and forth. On Desmos, when we go to type this in, you're going to go to Desmos, which I already have up, like we did last week, and you're going to hit this plus sign. And we're going to add in a table. We're going to add in a table of values. So I'd say study time is X. That's my input. How many hours did you study? And the output is your average. So my X column, I'm going to type in all these study hours. So I had someone study for, let's see here. I had someone study for, I want the Desmos keyboard. There it is. There it is. I had someone study for, what's the first one? I lost the photo. There it is. There it is. 2, enter. 4, enter. 5, I'm going down the column. I'm typing in all those X values there. 12, 17, 19, and 20. So those are the X values. Now I'm going to do the Y values. They have to match up. You can't do a random order. 2 goes with 64. 71 goes with 4. 69, 74, 81. I know it's tedious to type these numbers in, but it's not terrible. It's not terrible. 84. 84. I clearly missed something here. What did I miss? There we go. It goes 12, 14. This is why you got to be careful typing your data in. 14, 17, 19, 20. So 12, 14, 17, 19, and 20. So I typed in my data. And again, just like last week, I'm going to hit that little zoom button there, and it's going to show me that scatter plot. So there's my scatter plot here. I'm going to kind of zoom out just so I can see that x-axis kind of. There it is. There's my scatter plot. As x increases, well, what's x? X was the study hours. What tends to happen? Well, it looks like there's a strong linear relation, the positive linear relationship here. It looks like a line could go through that data, and it looks like it's going upwards. So I would say there is a linear relationship. There is a linear relationship because I can put that line of best fit through that data. Let me just export this. Export image. Medium rectangle. What's a medium square look like? I like medium rectangle, I think. I'm gonna copy image, and let's see if I can paste it into OneNote. See if OneNote's behaving today. There it is. It's a little tiny there. That's okay. There we go. There's my scatter plot. So it appears as x increases, I can draw a line through my data there. So there's a positive linear relationship here. Is there a positive correlation or a negative correlation? As study time increases, GPA tends to increase. So here's the line of best fit. I kind of sketched it in, but I'm giving you the equation. This is the equation of the line of best fit. Remember, lines are in y equals mx plus b. So that's my slope, and that's my y-intercept. Interpret the slope and the y-intercept in the context of this problem. So the y-intercept's the easier one. So let's start with that. Let's tackle what this y-intercept means. The y-intercept is my prediction. It's my prediction of y when x is 0. So what does that mean in terms of this problem? What do I predict y is going to be? Because remember, that's all this line is doing. It's just making a prediction. It's not actually what's going to happen. I'm just making a prediction about the data, about the relationship. So when it's my prediction for y, my GPA, we predict the GPA will be 62.47 if someone studies, right? That's what X is. Someone studies for 0 hours. So we predict that the GPA, we're predicting our Y value when X is 0. That's what a Y-intercept is. We predict the Y value will be this when X is 0. It's my starting point. It's the initial value. And my slope is a rate of change. Remember, the slope is the average rate of change. It's our croc. It's a real throwback there to the beginning of the year. So slope is the rate of change. It describes as x increases by 1. Let's start that again. We predict y will change by the slope when x increases by 1. So what does that mean? Let's go to the context of the problem here. We predict y will change by the slope. So what's y? GPA. And it's going up how much? That much. So we predict GPA will go up 1.68 when x increases by 1 for every additional hour of study. We predict that GPA will go up by 1.68 points for each for every additional hour of studying. So that's how we interpret slope and y-intercept, and we're going to do this in the next two videos as well. How do I interpret the y-intercept? It's our prediction for y when x is 0, and the slope is what we predict y will change by when x increases by 1. So that's how we can interpret our regression line here, our line of best fit. And we can use this line of best fit to make predictions. So I can give you an x value, and then we can use that line of best fit to make a prediction about a y value. So does the line of best fit overestimate or underestimate the GPA of a student who studies for 12 hours a week? So 12 hours is x equals 12. So let's plug that into our line. What does our line say my GPA is going to be? So if I plug that in there, let me go to Desmos here. I'm predicting, what did I say? 1.68 times 12 plus, what's that number? 6247 plus 6247. So when I plug into 12, that line spits back out 82.63. So 82.63 is our prediction. Now, is that an underestimate or an overestimate? So if I go to 12, that kid actually had a GPA of 86. But my line said 82, and that's okay, because my line was just making a prediction. So if I go to the scatter plot here, here's 12, right? 10, this is going by twos. Here's 12. The line underestimated that kid's score, but that's okay. We're just making a guess as what this line of best fit does. And finally, use the line of best fit to predict the GPA of a student who studies for 15 hours. So you're studying X is 15 hours. So we get to play everyone's favorite game, plug it in. So we're plugging in 15 into that equation there. So same thing, I'm going to go back there and just change that back to a 15. I predict the GPA will be 87.67. 87.67. I predict, it's just a guess, the GPA will be 87.67. So how do I use a scatter plot on Desmos? I can create a scatter plot by hitting the plus button and making a table. The key thing is you're going to hit plus and make a table. That's how we make scatter plots. And I'll see you in the next video.